All right, class, today we're going to look at graphing parabolas in the last form, intercept form. Intercept form gives us our x-intercepts. Sometimes it's also called factored form. You have two sets of parentheses generally. You don't have an x squared, you don't see a square anywhere in the equation. So our general form for that is y equals a, x minus p times x minus q. Your intercepts come from taking x minus p equals 0, so x equals p, and x minus q equal to 0, x is equal to q. So we get our x-intercepts, p comma 0 and q comma 0. Okay? They are two separate points. Okay? Now, because we know that the graph of a parabola is symmetrical, if I have 2 points P, Q, and they're both on the x-axis, our vertex is going to be halfway. So that's going to be halfway between P and Q. And to find the halfway point, we add them together and divide by 2, find the average. So to find our vertex, the x value is p plus q divided by 2. There's the algebraic method. Visually, a lot of times you can look at the graph and then find that point that looks like it's in the middle, and I'll show you that as well. And then you can plug in x to find the y of the vertex. Okay. You can graph with just these 3 points, the two intercepts and the vertex. So this makes this my favorite method because it's less work than all the rest of them. We don't actually have to make a table. So let's look at number 1. Y equals negative 2 times x minus 3 times x plus 5. Now my intercepts. Now if you can look at that and see that what they are, you can do that. But remember that it comes from doing x minus 3 equal to 0, so x is positive 3. And x plus 5 equals 0, we solve that and we get negative 5. That's our zero product property that we learned with factoring in Algebra 1. So my x-intercepts are 3, 0, and negative 5, 0. Okay, we have two separate points. And when we put this on a coordinate plane, we have 3, positive 3, negative 5, okay? And it looks to me like my middle is about there at negative 1. Doesn't that look? 1, 2, 3, 4 on that side. 1, 2, 3, 4 on this side. So let's check it algebraically. The x value of my vertex should be 3 plus negative 5 divided by 2. I get negative 2 divided by 2, which equals negative 1. Remember that that is also my axis of symmetry. So my axis of symmetry here is that vertical line through x equals negative 1. And then I can plug that in. Y equals negative 2, don't ignore that coefficient, times negative 1 minus 3, times negative 1 plus 5. So negative 2 times, do the parentheses first. There's something to do inside the parentheses here. So negative 4 times positive 4, I get negative 8 times 4, or sorry, positive 8, because negative times a negative is positive, is 32. Okay, so we're going to rescale this axis because mine doesn't go up to 32. So I'm going to count by 4s, negative 4, negative 8, negative 12. Oh, wait, it's positive. That makes sense because it opens down. Okay, right? We know that's negative, so it's going to open down. So my vertex should be at the top. So if I count by 4s, let's see, 28, 4, 8, 12, 16, 20, 24, and 32. I'm going to put this point up here. Up here at negative 1, 32. So my vertex, negative 1, positive 32. That is my vertex. And now I draw my parabola. Remember, this is U-shaped, not a V. Okay, if you want more points, you could plug in 0, see what you get. But that's not required. Okay. So all you need is your 2 intercepts, and then find your vertex that's halfway between, and then connect your dots. Your domain is all real numbers. Okay, let's talk about that. Domain, all real numbers. My range, the graph starts at 32 and is less than that, so y is less than or equal to 32. And that means I have a maximum of 32. Now this is one of those graphs that's increasing where x is less than -1 and decreasing for the x's that are greater than -1. We'll talk more about that tomorrow. Okay, next example. Y equals 1/2 times x plus 4 times x plus 8. So again, we're going to find my x-intercepts. X plus 4 equals 0, x plus 8 equals 0. So x is -4 and x is -8. You don't have to solve it like that. You can just go straight to writing them, but remember that we are getting the opposites. So -4, 0, and -8, 0. Okay, and then let's draw our graph. I like to put the x-intercepts on my graph first because it helps me kind of visualize where my vertex should be. So that's -4 and -8. And if I look closely, I can see that the middle is clearly -6. So I'm going to draw my vertical, my axis of symmetry through -6. And let's just check. -8 plus -4. It doesn't really matter which way I put those, P, Q, Q, P, as long as I'm adding them. Divide by 2 is -12 divided by 2, -6. And now let's plug it in and see what happens. 1/2 times -6 plus 4, 1/2 times -6 plus 8, and that's 1/2 times -2 times +2. 1/2 times -2 is -1 times 2, -2. So my vertex is at -6, -2. Now I'm going to graph that. And connect my points. Okay, and then we can say what is our domain? X such that x is contained in the set of all real numbers. Y such that y is greater than or equal to -2. That's the y value of my vertex. Has a minimum of -2. Again, the y value of my vertex. And this is the graph that is decreasing for x's less than -6. And it's increasing for x's that are greater than -6. Okay, last one. Y equals -x times x minus 3. This one usually messes people up. Okay, so notice again, there's no squares on the parentheses. I have 2 separate x's. So I have x, -x equals 0. So x is equal to 0 because 0 divided by -1 is 0. And then I have x minus 3 equals 0, so x equals +3. So my intercepts are at 0 and 3. So when I just have the x with no plus or minus anything, my intercept is at 0. And so we're going to put that on our graph like we did before, 0 and 3. Now halfway looks to me like it's between the 1 and the 2 at 1.5. So let's check it. X is equal to 0 plus 3 divided by 2. 3 divided by 2 is 1.5 or 1.5, however you like to write it. So then I'm going to plug it in to find my y value. Y is -1.5 times 1.5 minus 3. And that's -1.5 times -1.5, which gives me a positive 2.25. Now you can clearly, when you get fractions like that, your decimals, use a a calculator. Now, I prefer fractions. So if you put it in as negative 3 halves, and then negative 3 halves minus 3, you get 3 halves minus, put it over a 1, multiply by 2 over 2, 6 halves. We get negative 3 halves times negative 3 halves, which is positive 9 fourths, which is 2 and 1/4. Same thing. You don't need a calculator. Fractions, I think, are better. So we're going to put our vertex at 1.5, comma 2.25, or 3 halves, comma 9 fourths. However you want to write it. 2.25 is about here, and then connect it. So then again, my domain, x such that x is contained in the set of all real numbers. My range, y such that y starts at 2.25 and goes down. So is less than or equal to 9 fourths. Again, I prefer the fraction. And this graph has a maximum, the highest point. So the maximum is 9 fourths. And I don't know why I just wrote a 3. 9 fourths. Okay. And again, this graph is going increasing. If this was a roller coaster, it'd be going up first when it is left of negative or positive 1.5, and then it is down when it is to the right of 1.5. So it is decreasing for x is greater than 1.5 and increasing for x is less than 1.5. Okay. So your homework today is in the book. Go ahead and look on Canvas for the problems that you're supposed to do.